All right, this is our section of coordinate geometry. Well, the start of coordinate geometry that is going to talk about midpoint and distance. So we're going to move on to a coordinate plane, just like you used in algebra practically all year long, but we're going to tie a little bit of geometry in it. Okay, so we already talked about what midpoint is, and then you can have the length of a segment. So now let's see that on a graph. So we're going to investigate here and we're going to discover the midpoint formula. Let's start with finding the points, okay, or all the coordinates for A, B, C, and D. Okay, let me get my pen. Starting with A. A is at 2, 3. So let's write that down. B is at 10, 3. Okay, and then the midpoint is already identified in red. Remember, the midpoint is directly in the middle. Okay, it's halfway through. And so that looks like it's at 1, 2, 3, 4, 5, 6, 3. Okay, so that's for AB. Let's now look at CD, and then we're going to compare these values. Okay, so C is at 1, -1. D is at 1, 2, 3, 4, 5, 5, -5. All right, and then the midpoint is already there. It's halfway, and that one is at 3, -3. So now as we look at this little piece right here, it says, how does x1 and x2 together compare to xm? And then how does y1 and y2 together compare to ym? So I'm going to get my highlighter. Let's look at this one here. x1, x2, look at those two together. So when we say together, we might possibly think of the sum or the difference, okay? So just think about that. Now let's compare that to xm. So 2, 10, and then 6. Okay, so I can kind of already think of something right now. 2 and 10 together make 12, and then 12 related to 6, 6 is half of 12. So that might be something there. Now let's look at these next two. 3, 3, and 3. So all 3. So that's kind of hard to tell. But let's follow that same pattern like we just said. 3 and 3 together make 6. Oh, and 3 is half of 6 again. Okay, let's compare down here at the bottom, these x1 and x2. So x1 and x2 is 1 and 5. And then xm is 3. So same thing like we did earlier. These two together make 6. And look at there again, 6 and 3. 3 is half of 6. Okay, let's check that last one. -1 and -5. And then that one, -3. Those two together, -1 and -5 is -6, and half of -6 is -3. So I can already kind of derive this formula here, okay? If I take x1 and x2 and I add them together, how is that related to xm? It is half of that. So that's how the first coordinate is going to end up being. x1 plus x2 divided by 2, take half of that. And then same thing goes for y. Okay, and that will be your midpoint formula. x1 plus x2 divided by 2, comma, y1 plus y2. And that'll be your midpoint. Okay, here's another thing that I also want to look at. You can always look at it in terms of a table, okay, or a graph T-chart. Let's look at C and D. So if I write point C first, and C is at 1, 5, and then I put point D right here. D is at 5, -5. something to look at in terms of discovering what the midpoint is. Well, the midpoint is right there in the middle, okay? Exactly in the middle. Now, check out the differences between 1 to 5. How far apart is 1 to 5? Okay, it is 4 units long. How far apart is 5 to -5? Okay, 5, I'm sorry, it's not at 5. I wrote this wrong. Let me go back. See, that's what happens. We always make mistakes. So let's fix this. This is at 1, -1. And D is at 5, -5. There we go. Okay, so now I got the coordinates right. Difference now going from -1 to -5 is it's going down 4, okay? It's going down. This one's going up 4. This one has a positive difference. So half of 4 is 2. So if you add 2 to 1, that's 3, which is directly in the middle. Over here, -1 is going down 4, so we want to go down 2. So down 2 from -1 is -3. It's like minusing 2 here. And then that is another way to discover the midpoint there. Okay, so you can use a T-chart, you can use the formula, whichever way is easier. So sometimes, and depending on the problem, we may want to use this method right here. Okay. All right, so that's the midpoint. Let's go to now our investigation with discovering the distance formula. So it says find the length of RS. So how long is it? And it says turn the segment into a hypotenuse of a right triangle. And then it says recall a squared plus b squared equals c squared. So we've all done that before. That is the Pythagorean theorem. So let's do that. So I'm going to go ahead and make a right triangle here. Let's use red for the leg. So let's make it going like this and coming down right there. Okay, and so if you forgot Pythagorean theorem, you did that probably in 8th grade, I would assume, maybe 7th grade, I'm not sure. So let's figure out the lengths of these legs. So let's count here. So I usually call this one leg A, leg B, and the hypotenuse is always known as C, okay? The legs can flip-flop. So how long is leg A? 1, 2, 3, 4, 5, 6, 7, 8. So that is 8 units long. Leg B, 1, 2, 3, 4, 5, 6, 7. 7 units long. So you can actually use an old mathematical method of the Pythagorean theorem to find the length of a segment. Okay, and then there is another formula we're going to derive using that. So let's practice Pythagorean theorem. 8 squared plus 7 squared equals c squared. Again, I'm just following that formula right there. All right, so I'm going to need to use my calculator here. So I know that's 64 plus 49 equals c squared. And 64 plus 39 is 103. And then to get c squared by itself, we need to get rid of that squared. So what you do is you square root to get rid of that. And then algebraic always says whatever you do to one side, you must do to the other. So that's a proper property of equality to keep it equal. C is now by itself, and so the square root of 103 I'm going to put in my calculator, and that is 10.149. 10.149. Okay, so that is the length of RS, okay, using the Pythagorean theorem, something you were taught a while back. Okay, but the question is what if there's not a graph and we need to use a formula? Okay, so we're going to discover this formula. So let's start off by writing down these coordinates here. So the coordinate of R is 1, 2, 3, -4, 2. And the coordinate of S is 1, 2, 3, 4, 4, comma 9. All right, so let's go ahead and write that down. So R is at -4, 2, and S is at 4, comma 9. Well, we used Pythagorean theorem, which was the A, the B, and the C. So the question is how does X1 and X2 together compare to the length of the horizontal leg? So the horizontal leg A, just as a reminder, was 8. And then we're going to compare the Y1, Y2 to length B, which that was 7. So now I'm going to highlight here X1 and Y1. How does that compare to the horizontal leg? Okay, let's also take a look at Y1 and Y2. How does that compare to that one? Okay, so just by looking at those numbers, I think the blue numbers may ring a bell a little bit sooner. What could you do with 9 and 2 to get 7? We could subtract those. Does that work also for the 8? Yes, it does. Okay, so watch this right here. Ultimately, for the first one, to get B, if we take 9 and minus 2, that's going to equal 7. For X1 and X2, got to be careful on how you write this one out. But if you take the 4 and you minus -4, that gives us the 8. What do you do when you minus a negative? You ultimately add. So now think of that in terms of X1 and X2. What did we do? We took X2 and we minused X1. To get leg B, we took Y2, which was the 9, and we minused Y1. So we're going to use this right here in the formula to figure it out. So that way we know all we got to do is plug in coordinates X1, Y1, and X2 and Y2. All right, here we go. So let's use Pythagorean theorem, but instead of using A and B, we just said A was X2 minus X1, and B was Y2 minus Y1. So we're going to write that down, and then we're going to solve for C. So let's derive this formula. Here we go. So A is X2 minus X1 squared. B is Y2 minus Y1 squared. And we'll leave that as C squared because we're going to solve for C. All right. Now, the only thing we have to do is to get C by itself. So how did we get rid of the squared earlier? All we have to do is square root to get rid of that. And whatever you do to one side in the world of algebra, you must do to the other. Okay, so once you get C by itself, there's your formula, x2 minus x1 squared plus y2 minus y1 squared. Okay, and so there's your formula. And it seems rather lengthy, but if you want to find the distance between two coordinates, all you got to do is plug in those numbers right there, whatever those coordinates are. All right, let's practice using these formulas, okay? So here's a coordinate, or here's a segment on a graph, and it says find the midpoint and find the distance given this segment. So let's practice using the formula. So remember, the formula for midpoint is x1 plus x2 divided by 2. That'll give me the left coordinate, the x. And it's y1 plus y2 divided by 2. All right, well, it doesn't matter which one you call which, so I'm just going to call this one x1 and y1, and I'll call this one x2 and y2. All right, let's plug it in. x1 is -5 plus 3, and we're going to divide that by 2. y1 is 5 plus -9 divided by 2. All right, -8 plus 3 is -5. and then divided by 2. Negative 5 divided by 2 is negative 2.5. If you were to leave it as a fraction, that's okay too. All right, this one over here, 5 plus negative 9 is negative 4, divided by 2 is negative 2. So now, if we were to go graph that, let's go negative 1, 2.5, and then 2 down. There it is, perfectly right there in the middle. That's your midpoint. Okay. All right, let's practice using the distance formula to find the length. So this one was a little bit longer formula. So this one goes big radical x2 minus x1 squared plus y2 minus y1 squared. And now I already labeled them earlier, so let's just keep them labeled the same and let's plug in. X2 was a 3. X1 is a negative 5. Be careful with those negatives. Y2 is a negative 9 minus Y1 is a 5. All right, and don't forget, keep writing the radical every time because I've had students in the past forget to square root at the very end. So if you forget to keep writing it, you might forget to square root also. Here's a minus and negative, so I'm going to turn that into a plus, which that becomes an 11. And then negative 9 and negative 5 makes a negative 14. And then again, don't forget to keep your square root. I'm going to start working over here. 11 squared is 121. Negative 14 squared, think about what negative 14 squared is. That means negative 14 times negative 14. What's a negative times a negative? That is a positive. Okay, so anytime you square something, it's always going to be positive. Okay, don't make the mistake of leaving it negative. All right, so that's 196. 196 plus 121 is 317. And the last step is to square root. You can use your calculator. And that is about 17.804. So the length is 17.804 units. All right, there's that using those two formulas. Okay, let's just do one last example and that'll be it. So it says for problem example, it says for LN, which is a segment, okay, so segment LN, if L is located at negative 34.52 and the midpoint M is at 25, negative 16, where is the endpoint N? So let's draw a visual of this, okay? So L is here, so I'm just kind of estimating, okay, even if you were to, so it's up here in the number 2 quadrant, 1, 2, because it's negative 34, positive 52. And then M is somewhere down here, okay? And then, so if I were to connect them, and remember, M is the midpoint, so that means N is somewhere over here, and that's the point that we need to find, okay? So remember, this is the midpoint here, okay? So that piece is equal to that piece. That's the midpoint here. Here's L. The question is where is N, okay? So there's probably 2 or 3 ways you can do this problem, but I'm going to probably suggest using that T-chart, okay? Let me go back and show you that real quick again. So this T-chart right here that I'm about to highlight in yellow, this T-chart, okay? Remember, one endpoint C was at the top, the other endpoint D is at the bottom, and the midpoint is in the middle. And look at the distances and compare the distances that way. Going back to that one more time, remember from here to here, it's going to go up the same amount from there to there. So from 1 to 3, how big is that? 2. From 3 to 5, 2. So it's going to be the same because 3 needs to be exactly in the middle. Same thing here. From here to here, negative 1 to negative 3, it went down 2. Well, this needs to go exactly the same, down 2. So that has to be the same, and that does create -4. So I'm going to use the t-chart to figure this out instead of using the formula. So sometimes you do want to use the formula, sometimes you don't. Sometimes you want to use Pythagorean theorem to find the distance. Sometimes you want to use the formula. So that's the great thing about math. You can do that lots of different ways and still come up with the correct answer. So here's my t-chart. I'm going to do L first. L is at -34, 52. Okay, now I have my midpoint M, so I'm going to write that next. Okay, M is the midpoint, so that's at 25, -16. The question is where is N? So let's look at these changes here. How far does it change? Isn't it going to change the same amount because that M needs to be directly in the middle? All right, we may need to use our calculator because these numbers are kind of big. So how far is -34 to +25? It's going up, so it's going to be a positive difference. So 34, and I'm going to add 25 here. So this one goes up 59. So up 59. So guess what? It's going to have to go up 59 again in order for this to be true. That is directly in the middle. So let's add 25 plus 59. So here we are. This is going to be 84. Okay, now let's check out this other side. What is this other side doing? How far is 52 to -16? Is that going up or is it going down? It is going down because it's getting into the negative. So how far down does it go? It goes down 52 to the 0 and plus it down another 16. So I'm going to add 52 plus 16. So this one's going down 68. Guess what? It's going to go down 68 again, just like it did in the very beginning. So down 68. So I'm going to take 16 and I'm going to add 68. Or you can take -16 and minus 68. So there's a couple of ways you could do that. So this is actually going to be -84. Okay, so using a t-chart is a great way to figure out N. So point N is at 84, comma, -84. That's that coordinate way over there. All right, that's it.